Hello everyone, this is Pepri. In this video, we'll take a look at Microsoft Global Secure Access Internet Access. In the previous video, we configured the Microsoft traffic and tenant restriction. This time, we'll focus on internet access and see how to configure web filtering, TLS inspection, content policies, and prompt policies. Most of the examples shown in this video are based on my own testing environment. Since global secure access is evolving rapidly, some features may change over time. Before configuring security policies, internet access must first be enabled. This feature requires either an Entra Internet Access or Entra Suite license. Once internet access is enabled, users' web traffic is routed through Microsoft Global Security Access. This allows Microsoft to apply security features such as web filtering, TLS inspection, file control, and AI monitoring. Before we begin the configuration, let's first take a quick look at the overall architecture. This diagram was generated with AI and is intended only to provide a high-level understanding of how internet access works. As Microsoft continues to update Global Secure Access, some details may change over time. In simple terms, users' internet traffic is forwarded to Microsoft's Security Service Edge, where security features such as web filtering, TLS inspection, content control, and AI monitoring can be applied before user access websites and cloud services. Don't worry too much about every component here. We'll configure each feature step by step throughout this video. Now let's begin the actual configuration. Navigate to Traffic Forwarding, enable the Internet Access profile, and assign the users or groups that should use this service. Before enabling the Internet Access profile and assigning users to it, the Global Secure Access client will look like this. After the configuration is applied, the Internet channel appears as active in the Global Secure Access client, indicating that Internet access has been successfully enabled. The next step is to create the security profile. Internet access does not assign security policies directly to users. Instead, multiple security policies are grouped into a security profile. Users receive the security profile through conditional access. Think of the security profile as a container that combines multiple security controls into a single policy. For now, we'll skip this step and link the policy after it's created. Web filtering allows administrators to control access based on website categories or fully qualified domain names. Microsoft recently introduced version 2 of the web filtering policy, which provides a more flexible policy structure. Here I set the default action to allow. You can think of this as the difference between a blacklist and a whitelist approach. In this video, I block AI related categories. Now, let's link the policy we just created to the security profile. Security profiles become active only after they are assigned through conditional access. Here we target all internet resources protected by global secure access. Once the policy is applied, AI websites are blocked according to the web filtering policy. Before configuring TLS inspection, it's important to understand why this feature is needed. Without TLS inspection, global secure access can see where users are connecting, but it cannot inspect the encrypted HTTPS content itself. In other words, Microsoft knows that a user accessed ChatGPT or another website, but it can't see what files were uploaded or what prompts were submitted. Once TLS inspection is enabled, encrypted HTTPS traffic is temporarily decrypted within Microsoft Security Service Edge, inspected according to your security policy, and then re-encrypted before being sent to its destination. This allows internet access to inspect uploaded files, AI prompts, and web content, enabling features such as content policies, prompt policies, and data loss prevention. A simple way to think about it is this. Without TLS inspection, you're only looking at the shipping label on a package. With the TLS inspection, you are allowed to open the package, inspect its contents, and apply the appropriate security policy before sending it on. To enable TLS inspection, we first need to upload a certificate that Global Secure Access will use to decrypt HTTPS traffic. Enter the required certificate information such as the certificate name, common name, and organization name. Global Secure Access will then generate a certificate signing request or CSR, which will be submitted to your internal certificate authority. For this demonstration, I'll be using Active Directory Certificate Services as my internal certificate authority. The overall process is similar for other certificate authorities, but the specific steps may vary depending on your environment. Now let's submit the generate CSR to ADCS and request the certificate. For this demonstration, I selected the subordinate certification authority template. This worked well in my lab environment, although your environment may require a different certificate template. Open the CSR file with Notepad, then copy and paste the content into the request form as shown on the screen. The certificates need to be uploaded in PEM format, so before uploading them, we're going through a few simple conversion steps. First, select the base 64 encoded format, then download both certificates. Next, rename the exported .cer file to use the .pem extension. Now, let's create the TLS inspection policy. The default action determines whether traffic is inspected or bypassed by default. You can think of it as being similar to a blacklist or whitelist approach. If you don't create any rules, the policy simply follows the default action. However, some categories are configured to bypass TLS inspection by default, based on Microsoft's recommended exclusions. Before we can test the policy, the root certificate must be trusted by the client device. For this demonstration, I'll install it manually on a single test PC. In a production environment, you would typically deploy the certificate to all managed devices using a centralized management solution. I'll cover large-scale client deployment in a separate video. Some websites use the QUIC protocol, which may prevent TLS inspection from being applied. By disabling QUIC, the browser falls back to HTTPS over TCP, allowing global secure access to inspect the encrypted traffic. Once TLS inspection is working, content policies become available. Content policies can block uploads and downloads based on predefined conditions. If you integrate Microsoft Purview, more advanced content inspection become available, including sensitivity labels and classification. Prompt policies focus specifically on AI interactions. They can block malicious prompts or simply monitor user prompts for auditing purposes. For this demonstration, I'll focus on prompt logging and verify that prompts are being recorded correctly. Now let's enter a few prompts and test the policy. Based on my testing so far, prompt logging doesn't appear to capture every interaction consistently. However, this is still a rapidly evolving feature, so I expect it to improve over time with future updates. In this video, we've covered the basic configuration of Microsoft Global Secure Access Internet Access. Although the product is still evolving, it already provides powerful security capabilities by combining network, identity, and Microsoft 365 services. In upcoming videos, we'll explore client deployment, Microsoft Power BI integration, and more advanced policy scenarios. I hope you found it helpful. If you enjoyed this content, please consider subscribing to the channel, giving this video a thumbs up, and leaving a comment below. Thanks for watching, and I'll see you in the next one.